Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another lead code problem, that is House Robber 3. It's a medium level question and it's a very popular question, as you can see from the likes. Let's read the problem statement. The thief has found himself a new place for his thievery again. There is only one entrance to this area called root. Besides the root, each house has one and only one parent house. After a tour, the smart thief realized that all houses in this place form a binary tree. It will automatically contact the police if two directly linked houses were broken into the same night. Given the root of the binary tree, return the maximum amount of money the thief can rob without alerting the police. So let's take an example to better understand the question. So suppose this is an example. So all the houses form a binary tree. If the thief robs the house with a value 3, that is highlighted by orange, and if the thief uh, robs the directly connected houses, for example either of the 2 or 3, then there will be alerting to the police. So the thief can rob either the house with value 3 and these two houses, that is with value 3 and 1, right? Either the thief can rob the houses 3 plus 3 plus 1, that will be 7, or the thief can rob the houses 2 plus 3, that is 5, because 3 and this 3 and this 3 are not connected directly. 3 and 1 are not connected directly, but 3 and 2 and 3 and 3 are connected directly. So to solve this problem, we will first iterate the tree in a depth first search manner, right? DFS tree traversal. So at each node, starting from the leaf node, while moving up, so at each node we will return two values. So we will return an array of size 2. X represents the maximum value or the maximum money a robber can rob from the nodes or from the houses below this current house without alerting the police. And Y represents the maximum money the robber can rob from the houses below this current house plus the current house, the money he will get by robbing the current house, right? So the first value represents without the current house and the second value represents with the current house, right? Similarly, on the right hand side, it we will return the same, right. Now when we will uh, go back up to the root node, right, or the parent of these left and child nodes, what will happen? First we will calculate the maximum of whatever we are getting from the left child. So we are returning x comma y to z. So at z we will calculate the the maximum. So suppose the maximum is x from x and y. Similarly, we will calculate the maximum whatever you are getting from the right. So suppose the value is y dash, that is the maximum. So at root z or the parent root, what we will do, we will first, to calculate the first value of the resultant array, we will take the maximum left and the maximum right, right? So and we will add them, and the value, and that value will be the first value of the resultant array. So suppose the value is a, and for the second value of the resultant array, we will take the first value of the left and first value of the right. So now that's very important. Why we are taking only the first value? Because if the robber robs this house, the robber cannot rob the left and the right child, right? So we cannot take y and y dash, because y and y dash represent the maximum sum of the money that the robber obtained by robbing the houses below this node plus the current node, right, that we discussed, right? So y represents the money including this node, and y dash also includes the value of this node, right, or the money robber will get by robbing this house also. So we cannot take y and y dash, we have to take x and x dash, because they represents the maximum value the robber obtained by not including this left and right child. So as we are robbing the parent, node, we cannot take left and right. So we will take x plus x dash plus the current value of the node, that is z. So it will be x plus xz plus z and b, and from the root node we will return a comma b. Now let's see an example to better understand uh, the approach that we talked about. We've taken this example, so we'll iterate in the DFS manner, right? So well, we will go from start from the root node, that is 1. We will go to 3, then we will go on the left side, but on the left side of 3, that is null. So we'll return 0 comma 0. We will return an empty array of size 2, right, with a default value 0 comma 0. Now we will go on the right. So on the right we have again 5. So from 5 we will iterate left, that is 9. From 9 the left child is null, so we'll return 0. On the right again we have null, so we'll return 0. Now at 9, what we have to do, we have to again perform two operations. First we have to calculate the maximum of left. So from the left we are getting 0 comma 0, so we have to take the maximum of 0 comma 0, that is 0. On the right we are getting 0 comma 0, so what is the maximum, that is 0. We will calculate the result 0, the first value of the resultant array, that will be the max left, that is 0 plus 0, that is 0. And now the second element of the resultant array will be the left 0, the first element of the left, that is 0, and the first element of the right, that is 0, plus 9, the current node, right, that will be 9, so we will return 0 comma 9. Now at 5 we will go at right. So again at right we have null, so we will return 0 comma 0. Now again at 5 we will perform, we will take the maximum of left. So left is 0 comma 9, so maximum is 9. On the right the the value is 0 comma 0, the maximum is 0, and the first value of the resultant array will be 0 plus 9, that is 9. And for the second element of the resultant will be left 0 plus right 0, so it will be 0 plus 0 plus 5, that is the current node, that will be 5. So the value returned from 5 will be 9 comma 5. Now at 3 we will again do the same. So at 3 we are getting 0 comma 0 from the left, so the maximum is 0. On the right we are getting 9 comma 5, the value is 9, the maximum value. For the first element of the resultant array it will be max left plus max right, that is 0 plus 9, that is 9. The second element will be 0 plus 9 plus 3, that is 12, because left 0 is 0, right 0 is 9. So 9 plus 0 plus 3, the current node, that is 12. So we will return 9 comma 12 from 1. Now at 1 we will traverse the right tree. So we will go from 1 to 6 and then to 7, right, till we reach the leaf node. So 7 is the leaf node, as it's the left child is null, so we'll return 0 comma 0. The right child is also null, we'll return 0 comma 0. At 7 we will again perform the same procedure. We will calculate the left, the max of left, that is 0, max of right, that is 0, resultant 0, that is max plus max right, that is 0, and the second element will be left of 0 plus right of 0 plus 7, the current node, that is will be 7. So we'll return 0 comma 7. Now we will go on the right side of 6, that is 4. So 4 is the leaf node, as from left child is null, we'll return 0 comma 0, right child is null, will return 0 comma 0. We'll again perform the same operation and will return 0 comma 4 from 4. And at 6 we will again do the same. So for 6 we are getting 0 comma 7 from the left and 0 comma 4 from the right, that and the maximum is 7 and 4 respectively. So the first element of the resultant array will be max left plus max right, that is 11, and the second element will be left of 0, that is 0 plus 0 plus 6, the current node, that will be 6. So we'll return 11 comma 6 from 6. Now at 1 we will again do the same. So left we are getting 9 comma 12, and for right we are getting 11 comma 6. The maximum will be max left plus max right for the first element, that will be 12 plus 11, 23. And for the second element that is left 0 plus right 0 plus 1. And finally, we will take the maximum of 23 comma 21, that is 23. So finally we'll return 23. So let's see the code part for it. So I have coded this in Java language, right? So this is the class solution. I have created a function that is int rob, which takes the root tree node. And I've also created a auxiliary method that is rob sub that takes the root node and returns an array of integer of size 2. So we are first checking if the root is equal to null. We are returning an empty default 0 comma 0 with size 2, right? Uh, that will be our base condition. Now we are iterating the left child till we reach the leaf node, and then the right child, right, usual DFS manner, and each left and right child will return an array of size 2. So finally, at any leaf node, once we reach a leaf node, we will create a resultant array, and we will first the first element of the resultant array will be first we will calculate the maximum of left 0 comma left 1, right? So the maximum of either of the two of the left child, and maximum of either of the two from the right child. And the second element of the resultant array will be the current node plus the left 0 plus right 0, as we talked about that the right 0 and right 1 will contain the value of the left and the child node also. So we have to skip when we are robbing the current node. So we have to skip the left child and the right child. So we will only take the left 0 and right 0 that represents the maximum sum without the left child and the right child respectively, and will result and we will return the result. And finally, in the main method, we will take result as an variable and will return the maximum of result 0 comma result 1. So let's try to run this solution. So yeah, test case. So let's talk about the time and space complexity. So time complexity, as we are iterating each element once, right? It's a DFS traversal, so the time complexity will be big O of n in the worst case. In the worst case, where n is the number of elements, and space complexity will be again n if the tree is skew or left sided tree or right sided tree, and where n is the number of elements. So I hope you enjoyed watching this video. So guys, please share and subscribe if you have watched till here. So it will give me motivation